Okay, I'm back. I went over to print some normal tables, so I wouldn't have to hold that whole book over my sheet here. And we have two example questions here. One is, find the approximate probability x is at least 20. So 20, at least 20 is 20 or more. So 20 is here. So I have to come on this side and go that way for at least 20. And so the way says, okay, at least 20. Another one says at most 20. At most 20 is 20 or less. There's 20 or less. At most 20. Like that. So we find the area on the left-hand side for at most 20, and the area on the right-hand side for at least 20. So to get at most 20, we're going to use at most 20. We're going to use this place right here. This is the bar that's over 20. So we're going to use 20.5 in the formula. Use 20.5 in Z. And for at least 20, we're going to use at least 20. We have to come back here on the other side of 20. That's 19.5. Use 19.5 in Z. Okay, so we'll compute Z here with 20. And it was 20. The mean was 18. Kind of forgot what the standard deviation was. It's back here. 3.1464. And down here, I'm going to compute a Z now using, oh, it's 20.5. Almost messed up. 20.5. There we go. Here, 19.5 minus 18. 3.1464, like that. Okay. Let's get those computed. Are we ready? I guess we are. So if you don't want to use parentheses when computing these Z formulas, you can do it like this. You just compute the top, 20.5. Well, I'm doing this one. Minus 18. And then you hit enter. The top is 2.5. And then you hit divided by. It'll take that answer and divide it by 3.1464. Okay. 0.7945. We expected a positive answer because 20.5 is here. It's above the mean of 18 a little ways. That's how many standard deviations. The standard deviation was 3.14. So 18, that's one standard deviation. It's not quite one standard deviation above. Do the same thing here. Oh, now I can't use second enter. So I'll just try it again the same way. 19.5 minus 18, hit enter, divided by 3.1464. Okay. So that's 0.4767, like that. And then we're going to go to the tables. I brought them here. 7, 9. We're going to use 7, 9. We used minus 0.79 before, but our position was exactly the same distance away on the other side of the mean. That's interesting. So here we are with the tables. Maybe I'll just zoom in for a second. We're looking for 0.79. Here it comes. 0.79. I'm covering it up. How about now? Might be all right. A little bit more. There you go. So 0.7's here, 0.79, slide all the way over here. 7, that's 0.9 up there, 0.09 on top. Come down here. We're at 0.78, so 0.7852. The tables give 0.7852. for 7, 9. And then where the other one is 4, 4, 6, we're going to use 4, 7. I'm going to use 4, 8. Where are we? We're here. Use 4.48 in the tables. And off we go to 4, 8. So 0.4, this 0.4, 0.48. It's way up here. 6844, okay. 0.6844. Okay, so we're getting close. Let me zoom back out so we can see what we're doing here. There we go. So now I just have to worry about whether I accept that value or have to mess with it. So at most 20, I want the area on the left-hand side. Here's at most 20. There's 20.5. There's the answer. So this is our answer. And if we compare it to the exact answer up here, 7869. So I went to some probability tables and looked that up. 20 or less probability was 7869. And here is the approximate answer, 7852. Pretty good. And then over here, when we're doing at least 20 is the wrong side. So what we found was the area on this side in the tables, all the way on this side. So we don't want this, which is what the tables gave us. So we're going to 1 minus that for at least 20. So your answer is going to be 1 minus 0.6844. Okay. So 1 minus 0.6844, like that. And I get 0.4767. And up here, we're looking at what it is. Here's what happened with the true answer. The real answer is really close to the number we got. We got 6844. It was 68441. Nice. And so this answer and the theoretical answer match quite closely. So that's exciting. Let's recoup where we are. So we've done 3 calculations so far. The first one involved finding the probability x is some number. We had to use z-values corresponding to that number plus or minus a half. So we get the area of this bar. So we did that, got z's, and then of course, from the z's, we find proportions below, or probability of being below. We subtract those probabilities to be the probability of being equal. Compared it to the true answer, it was pretty close. And then we had these other two, at most or at least. At most means that much or less. At most means that much or less. And so we'd want to shade to the left, and we want to include the bar because you can be 20 if you're at most 20. So you start at 20.5 and go left. You compute z for that, you get this, go to the tables, it's your answer. If you want at least 20, then it has to be 20 is allowed or more. So we want to subtract out the stuff we can't use. So that would be on this side, 19, 18, 17, so on. None of those are at least 20. And to cover those, I have to start at 19.5 and go left. So I put 19.5 into the z formula. I got 0.4767. I used 0.48 rounding. I went to the tables, but that's the wrong side. I want the right-hand side, not the left side. So the total area is 1 in probability terms. So I take 1 minus that 0.6844 and got 0.4767 as my answer. Okay, level 2 complete. I'm getting ready for the final calculation.